Hello everybody, I'm Jonathan and I'm doing a presentation on the artificial heart. First I'm going to do a small overview, introduce the human heart, major reasons for developing the artificial heart, a history of the artificial heart, and then going into design and function and what the ideal heart should be for what they want. The heart, as we know, is the muscle that pumps blood to our human body. This is the four chambers, the left and right atria, which receive blood, and then the left and right ventricle, which are the pumping mechanisms that pump blood out. It has an average resting heartbeat of 60 to 80 beats per minute. Okay, some reasons why a person might need a heart transplant. Coronary artery disease, which is the thinning of the artery walls due to mostly diet. And you have cardiomyopathy, which is just a disease which eats away at your heart and destroys the muscle, the actual heart. You have heart valve diseases. Sometimes people are born or their valves start to decay and they're no longer good. Retransplants. Some people need a new heart after a certain amount of time because the one they receive no longer works. And then you have congenital heart disease, which affects mostly infants. They're just born with bad hearts and they need to be replaced. The estimate is about 100,000 people in the U.S. would benefit from a heart transplant. Some examples: 1 out of 5 people in 2008 died while waiting on the heart transplant list. These are the people that were eligible for a heart transplant and they still died because there wasn't heart available for them. And as of May 27, 2011, there is 3,177 candidates on the heart transplant list, and there's only about 2,500 hearts available per year. The history: in 1957, the first implanted heart was introduced. It was performed on a dog. It only survived for 90 minutes and then expired. The next big moment happened in 1969 when the first actual implant went to a human being. However, this was only temporary. And the person stayed. They implanted the heart for about 36 hours, and then they removed it and put a donor heart in. The person died 38 hours later because of complications with the surgery. Then in 1992, the first actual permanent implant occurred. Here the person survived a little longer, as you can see, 112 days. This is the UCR7. However, the person died after those 112 days because of blood clots, which created a stroke. And then up to the future now, we have 2001, the AV4 heart was introduced. This heart is one of the best hearts out there right now. As you can see, one patient survived for 112 days after receiving the implant. Basic function of the heart. This is the AV4 heart. There's a couple of different models, but this is the best one so far that I can find. You have an external battery pack, provides a battery to the system inside. It's done through a transcutaneous energy transfer system. It's a capacitor inductor system where you have an inductor on the outside. This creates when current is passed through, creates a magnetic field, which creates current inside an inductor that's inside the person. So you don't have to pierce the skin. You can just transfer energy without having to have some kind of incision made, so it just goes right to the skin. That energy is then transferred to a control system. The control system monitors the pump, and there's also a battery connected inside the person. This is like an emergency pack in case something happens to the external pack and it needs to be removed or replaced for some reason. It only lasts up to 20 minutes. It's also useful when people want to take showers. They can just take out the outside battery, and then take a shower like normal. The actual pump is a centrifugal pump. It continuously rotates hydraulic fluid inside in this centerpiece here. In there's a valve which can move from left to right. This valve pushes the hydraulic fluid either from the left side of the heart or the right side of the heart. When the valve is positioned to the left side of the heart, it forces a balloon inside the heart to bulge out due to the pressure of the hydraulic fluid. This causes a valve or a compartment outside that balloon to create pressure, which forces the fluid out to the human body. And when it's positioned to the right side, it forces the other way out to the lungs. So you get you change the oxygen out. first clinical trial for this specific heart, there was 14 people implanted. One of them died during surgery, so only about 13 people actually were using the heart, and they averaged about 5 months after surgery, and then they passed away. The ideal heart for what most scientists are striving for is one which has no external power, so all the components are inside, and you don't have to worry about any type of infections. The vehicle heart kind of handles this with the transcutaneous energy transfer system that it has. So there's no actual cords sticking out of the person, which creates diseases and whatnot. It doesn't cause blood clots. Some of the hearts out there, due to the way the mechanism they have, destroy a lot of the blood cells, and this eventually forms blood clots inside the person, which creates strokes, and strokes are bad. Well, what everyone wants is to return the full quality of the heart, so pretty much they want a normal human heart. Then you have long-term use. As you can see, most of the hearts right now, they average maybe 7 to 9 months tops. The longest one was 712 days. The person survived on it and then passed away. It's affordable. The vehicle heart, the model alone is $75,000, and then an additional $150,000 for the actual surgery. So as you can see, it's not really affordable right now, but that's what they're striving for. And then the last one just doesn't cause infections. Like I said, if you have sticks sticking out, you have bacteria that can go in there, and then infections are bad. Any questions?
Questions? Anybody have questions for Jonathan?
So I noticed that you said that there was typically like a 5 to 9 month lifetime on these devices when you implant them into somebody. What sort of advancements are being made to try to extend that lifetime?
Well, the EVCAR, the same company is coming out with a new model. Some of the Spanish with that one is that it was too bulky, so only about 50% of the males with the original one could actually wear it, or the male population in the United States, no females because it was too large to the chest. So with the new one, it's supposed to be a lot smaller so that people, it'll be inside smaller people, and more people will be able to use it.
So you said like people expire after like 90 days or a few months of use. Is it possible to, I guess, double up on the heart? Like say, if you know you're about to die because of a bad heart, can you get another artificial heart as your second one or your third one?
I mean, a lot of these hearts are also used in conjunction with donor transplants. They'll put in the heart for a certain amount of time, and then they'll wait on the waiting list until they actually get a donor heart. But like I said, there's not a lot of donor hearts out there, so either way, if they don't receive them, they have to stay on it. And there's, like I said, blood clotting occurs with some, and then that creates the strokes, and then pass away.
Okay, so it's more temporary than not a permanent.
Yeah, they're aiming for a permanent one. Like I said, the EVCAR only has, that was the first clinical trial, which only lasted about, the average was 5 months. But these were the worst people. These were people that were going to die within hours if they didn't have a heart transplant. So I mean, that's pretty good compared to.
How is this one different than Jarvik?
The Jarvik?
Yeah.
The pump is different. Also, the way that the energy that they transfer energy into the system is different. So, like I said, due to the transcutaneous energy system, they don't have tubes coming out of the person. The pumps are also different. Like the Jarvik had a lot of problems with the blood clotting, because of the way circulated blood, it destroys a lot of blood cells, and that creates a clot.
Any other questions? Okay, so let's move on to the next.